Hi, this is Mr. Ward, and I'm doing a quick key for Do Now 14.2. And I've listed some of the basic properties that we've worked with so far: the addition, division, multiplication, substitution, transitive, and substitution properties, which are all part of what we've been doing with geometry. But there's one more I want to add, which is kind of a Captain Obvious property. It's the reflexive property. The reflexive property simply means that things are congruent to themselves. So ZW is congruent to WZ. It's the same thing. That segment ZW is the same as WZ. So, or angle XZY is congruent to angle YZX. It is so Captain Obvious that it is often overlooked as something you can use, but it's actually very useful in a lot of proof stuff. So here it is. Here's the formal thing. It's a postulate, which means it's a thing we can assume. Any segment or angle is congruent to itself. Things are themselves, but sometimes they get named in backwards ways. So for number one, we need to justify conclusion A that angle ADC is congruent to angle ABC. We had to pick from those 7 principles which one would allow us to prove it. We're given some information. M and N are midpoints. That doesn't help us with the angles. DC is congruent to AB, and AB is congruent to DB. That doesn't help us much with that one. But angle 1 is congruent to angle 4, and angle 2 is congruent to angle 3. So that does help us, because by addition, and that's the property we're looking for, addition will allow us to prove that conclusion, because the sums, because when you add congruent angles to congruent angles, not angels, you get congruent sums, okay? Because 2 plus 1 is going to be the same as 3 plus 4, because angle 2 and 3 are the same, angle 1 and 4 are the same. So if I add angle 2 to angle 1, that's the same as adding angle 3 to angle 4. They are the same thing. You could also use substitution in there, but addition is probably your best bet. All right, let's look at conclusion B. Segment CM is congruent to segment AN. Well, we know that M and N are midpoints, which means that we know that DM and MC are congruent. We then know also that AN and NB are congruent. We also know that DC is congruent to AB. Okay, so you're going to be using a couple things. One, the main one is division property. You can ultimately use the division property because if you divide, actually, we don't even need to use the substitution property. We just know that CM is half of something that's congruent to this one, and AN is half of this one. So we divide two congruent segments, you get congruent quotients. Okay, so but it don't need to be segments. It could be anything. We'll just say things. It could be angles or segments. Okay, you could probably have also taken a substitution route for this, but I think your most straightforward route is division. Conclusion C. Segment BD is congruent to segment DB. Now, this is BD and this is DB. They are the same dang thing, so reflexive property, because segment BD is the same as segment DB, just with a different order in the name. Okay, And then the last one of the problems you got to do, other than just explaining how you're doing with things, is D. Segment DC, this is DC, is congruent to segment DB. Well, we know that DC is congruent to AB, and AB is congruent to DB. So for this one, we're going to use the transitive property. That is probably your best bet, because we can say we know DC is congruent to AB, which is congruent to DB. So DC is congruent to DB. Like that. All right, I'll stop sharing, and I hope that was